Hello everyone. In our previous 3 videos, we solved 3 different types of experimental questions, and this is the 4th video, and it is about back titration. And in my opinion, it is one of the most difficult type of experimental questions. And most students struggle with this type of questions, and it is really very difficult to perform calculations and follow its step. It requires a lot of steps in the calculation. So let me read the question before we start solving. We have an eggshell, and eggshells contain calcium carbonate along with impurities. What does it mean? We know the eggshell mass, but it doesn't belong to calcium carbonate only. It also consists impurities inside it. And we assume that impurities never react with the acid, so this makes our calculations easier. And 10 grams of an eggshell are placed into a beaker, and then we add 50 centimeter cube 5 molar hydrochloric acid on it. This is the highly concentrated acid, and we add a big portion of the acid on eggshell so that we should be sure that all calcium carbonate reacted with hydrochloric acid. And after allowing them to react, the impurities are filtered off and the solution is diluted to a total volume of 100 centimeter cube. Out of this solution, we use 20 centimeter cube portion. You know it from our previous videos. It's really difficult to make titration with 100 centimeter cube. It's a huge amount of volume. It will take a lot of time. So we use a smaller portion inside it, which is 20 centimeter cube in this question. And it is taken and is titrated against 1 molar sodium hydroxide, and 42 centimeter cube is required for the neutralization. And question says calculate the percentage of calcium carbonate in eggshell, assuming that none of the impurities react with hydrochloric acid. So how do we start this type of questions? I suggest you to draw diagrams to follow the question. So you have an eggshell, and some of it is calcium carbonate and the rest is impurities. And only calcium carbonate reacts with hydrochloric acid. So on the eggshell you add 50 centimeter cube 5 molar hydrochloric acid, and you allow them to react. So which reaction occurs between calcium carbonate and hydrochloric acid? They form calcium chloride, carbon dioxide and water. And to balance the equation, we need to put 2 at the beginning of the hydrochloric acid. So what happens at the end of this reaction? All calcium carbonate is consumed up, but some of the acid remains excess. So we don't know how many grams of calcium carbonate do we have at the beginning, and also we don't know how many grams of hydrochloric acid is used up, or how many moles. So what can we do? We can determine the number of moles of hydrochloric acid remained by doing a back titration with a known concentration of base. In this question it is sodium hydroxide. So hydrochloric acid will react with sodium hydroxide to form sodium chloride and water. So if you calculate the number of moles of sodium hydroxide, then you calculate the number of moles of hydrochloric acid. And by using this, you can subtract this number from the initial number of moles of hydrochloric acid, and then you find how many moles reacted with calcium carbonate, and then you determine the number of moles of calcium carbonate, and then you determine the mass of calcium carbonate, and finally the percentage in the eggshell. This is the eggshell. Okay, so what we do, after we make this reaction, they filter this off to remove the impurities, and they dilute it up to, let me check, 100 centimeter cube. So the total volume is 100 centimeter cube here, but we use a smaller portion, which is 20 centimeter cube. So you have 20 centimeter cube of remained excess hydrochloric acid solution, and you titrate it against sodium hydroxide, which is 1 molar, and 42 centimeter cube is required. So concentration is 1 molar, and volume is, let me check again, 42 centimeter cube. As you know, we need to convert this into decimeter cube by dividing it to 1000. So number of moles of sodium hydroxide is the multiplication of concentration and volume, which is 1 molar times 42 divided by 1000. And it is equal to 4.2 times 10 to the power of minus 2 moles. So by using the stoichiometric ratio between hydrochloric acid and sodium hydroxide, we can easily see that the mole ratio is 1:1 because the coefficients are 1. So number of moles of hydrochloric acid must be also 4.2 times 10 to the power of minus 2 moles. And this is the number of moles of hydrochloric acid in 20 centimeter cube portion. But the original solution was 100 centimeter cube, and this portion is 1/5 of the original solution, so we need to multiply this by 5. And when we multiply this by 5, we find the number of moles as 0.210 moles. Okay, so we know the number of moles of hydrochloric acid remained, and we know the initial number of moles of hydrochloric acid if we multiply these two. So number of moles of initial acid is the multiplication of its concentration and volume. Again, volume must be converted into decimeter cube. So 5 molar times 50 centimeter cube divided by 1000 gives us 0.250 moles. So we know the initial number of moles of the acid, we know the remained number of moles of the acid, and the difference between these two gives us the number of moles of the acid reacted with calcium carbonate. So when we subtract 0.210 from 0.250, we find the number of moles of hydrochloric acid as 0.040 moles. And the mole ratio between calcium carbonate and acid is 1 to 2, which means number of moles of calcium carbonate is 0.020 moles. So now we know the number of moles of calcium carbonate, and we need to calculate its mass. And its molar mass is 109 grams per mole if you calculate the molar masses by using the periodic table. So mass is equal to number of moles times molar mass. So you multiply 0.02 times 109. Let me calculate it. What do we have? 0.02 times 100.09. It gives us 2 grams. So initial eggshell was 10 grams and calcium carbonate is 2 grams. It means 8 grams of impurities are found in the eggshell. So what is the percentage of calcium carbonate in the eggshell? You divide the mass of calcium carbonate to the mass of eggshell, multiply by 100, and you find it as 20%. And this method is called back titration. It is a very useful method actually to determine the unknown amount of calcium carbonate in limestone or in the eggshell. I hope you liked the video. If you have any further questions, please do not hesitate to email me. I will reply it as soon as possible. Thank you.